Okay, so today we're still in chapter 11 like we were last class. And we're still going to study the hypothesis test. And the confidence intervals, but now on two samples of paired numerical data. So remember, right now we're just studying numerical data. We don't have to think about if it's numerical or categorical, but I do want you to start when you're reading a problem, just recognize why it is numerical. We know it's numerical up front, but just why is it numerical? So let's address this paired or dependent data. So in Minitab, we're going to see the word paired, just so you know. But you can call it dependent or paired numerical data, whichever one you want. So I'll write both here. So this is where we're going to study two samples. When the second sample is intentionally chosen to match up row by row. With the first sample. So that's when we have dependent or paired data. It's when that second sample matches up row by row with the first sample. Here, we must have the same sample size. We must have it. Okay, we must have that same sample size. So I'm going to just show you what we talked about last class and show you how this is going to be different this class. So actually, let me do this. So last class, we had two samples, right? And we took the mean for sample one. And we had a second sample, and we have the mean of sample two, right? And what we did was we compared the difference. We wanted to see if there was a difference. So we had mu1 minus mu2. So we compared these two means. And we looked at the difference of the means, right? We looked at the difference between those two means. And now this class, so now for today, what we're looking at the mean of the differences. Okay, so this is actually called mu d. And what we're going to study is the mean of the differences. So what we're actually going to do is we're going to subtract first sample one and sample two, and then we're going to take the average, so the mean of those differences once we subtract. And this is actually a better study, what we're going to do today. Okay, so it's improved from this study. And it actually cuts down on the variability. So it's an improved study. So I just want to write that we're going to, kind of want to write this someplace. Calculate the difference than the mean. So here we only have one mean, and it's of the differences. Over here we had two separate means, and we looked at the difference of those means. Now, you guys, this is why I mentioned last class. Let me zoom in a little. This is why I mentioned last class that some of the wording of where the word difference is compared to the word mean matters. This is called mean difference, mu-d, mean difference. This one is here is the difference of the means. So the location of the word difference and mean matter to us, okay? So let's just take a look at, and talk about a little example. We won't work through this example, but just a little example of what we would be doing. So for example, and this is happening, I think actually in our class right now, siblings, right? Yeah, and you know who you are, siblings at RIT. Okay, and maybe I want to know and study the stats 2 grade between siblings. Okay, so and this happens to me, every once in a while. I've had a sibling and then I have another one, and they say, oh, you have my brother or my sister, a year ago or whatever. It's pretty funny. But maybe I want to study siblings at RIT, and I want to study their stats 2 grades, right? Their overall grades. So I wouldn't have that for this semester. So the student that I have here. But maybe I'm looking at, okay, I'm just going to number these rows. I would probably go down more than 5, but and then maybe I'm going to look at the oldest or the older sibling and then the younger sibling. And I'm just going to look at their grades, right? So, this is not real data. I'm just making stuff up here. So maybe older sibling for row 2, and then the younger sibling, right? So these two are completely linked, had a 90.2, right? Something like this. I'm just going to fill in some numbers and we can kind of talk about this. So again, I'm just making these numbers up. Nothing like collected here. So what we're looking at is we want to see, okay, is there a difference between these groups, right? Is there a difference between the older siblings and the younger siblings' grades in my Stat 2 class? So we have to realize, well, what is it that's making this dependent or paired? First of all, when I look here, I have the same sample size. I have 5 older siblings and 5 younger siblings. And then I need to know, well, what is it that's making them linked, right? What links this person to this person? Well, it's that these two are siblings. So these two are linked directly. It's ordered. So I can't change the order, right? This person is the sibling of this person, and same with all of these. Okay, and that's how paired data works. So there's something that's linking them. They don't have to be related. It could be on the same person. You're going to see like in today's example. So there's different ways of linking someone to another person. And, on the daily last week, it was, we studied different jobs and their salaries for different cities, right? But it was the job, right? The specific type of job is what linked someone from one city to the other, which made it paired or dependent. Okay. Sometimes it can be very tricky to figure it out. I try not to make it tricky. I try to make it really straightforward on an exam, just so you guys know. I try to make it so simple for you to figure it out that it's paired. But that's what we're looking at. So when we're looking at this kind of thing, what we're going to do is we have these two, and then we're going to have another column of data, which is going to be like older minus younger. right? And we're going to subtract these two. So we'll get these numbers here. And that's going to be my differences, right? So right here, this will be my difference column. And sometimes I have to do this myself. And I will show you in Minitab how to come up with this difference column. So this is really the data that we're studying. Let me just write that. So now we're not really looking at older and younger separately. Now we're looking at the differences. So that's the column we're going to be studying. Okay. And we're going to look at D bar. So D bar is very similar to mu bar, and this is going to be the mean, right, of my sample, right? Or we can say the average of that sample of the differences. I'm just going to put sample here so we understand that it's for my sample. So that's my D bar. And here's still my sample size. And remember, the sample size is the same, so it's just 5. And then I have SD, and SD is the standard deviation. Of the differences. And then we have mu D. Mu D is the mean of the differences. So for this example, it's going to be the mean of the oldest minus the youngest. Okay. These are the values we're going to be looking at. You guys, you know we don't have to calculate any of this stuff by hand, right? You know Minitab's going to do all of this. It's just I need you to understand what Minitab's doing behind the scenes for us. And actually, Minitab will make this column itself behind the scenes for us, but we need it for checking our requirements, which we're going to look at here next. So if we're just running the test and we're not checking requirements, you don't need to come up with this difference column. But in order to check your requirements, you're going to need it. So for the Minitab test and CI, you don't need to do this just for checking the requirements, but Minitab just does it behind the scenes for us. So let's check these requirements and these assumptions for this test. We already know what they are. So my requirements here, we have 2 requirements, right, for our T test. So we need to check for normality. So, but we need to check for normality in the differences. And this is where it changes for us. So, and I'm just going to say between the 2 samples. Okay. So again, you can check that n is greater than or equal to 30. That's the easy one. Or we can check the NPP with the normality test. I just want you to know that when we're doing these, it's on the differences. So this is going to matter. That's this new column where we subtracted them. Okay. And then the other one is we need to make sure there's no outliers. I'm going to check for those outliers. So we don't want any outliers, right? So no outliers for this one. And again, it's on the differences. So we will build a box plot. For the differences. So this is the one where we're going to make a new column and we can check our requirements. Okay, I will show you how to do this in MATLAB. It's just a few steps you have to take before you can run these tests, but nothing too tricky. Okay. So let's take a look at what we're going to see for a confidence interval and for our hypothesis test. So for our CI, remember the requirements are for both. So for a CI, as usual, we're looking at point estimate plus or minus margin of error. Remember my point estimate, I'm looking for the best estimate for the population mean of the differences. And the best estimate for mu D is going to be D bar, that sample mean. Okay. So D bar is our sample means, like our X bar, right? And of our differences, and that's going to be the best estimate for mu D. So let me just kind of write that. Best estimate for mu D. Plus or minus our t value at alpha divided by 2. So nothing new there. And then our standard error. And I'm just going to write our standard error formula, but it's still the same thing. It's my S divided by the square root of n. It's just my S is not just S right now. It's SD. Remember, I told you on the previous page, that was my standard deviation of the differences. So this is still my standard error here. Okay. And this still represents the number of standard errors away from our center, which is D bar. Okay. This, of course, depends on, depends on two things: degrees of freedom, which again comes back down to n minus 1 because n is the same, and my confidence level. Okay. When we're looking at a CI, of course, we want to interpret our CI, and it's the same as last class. It's just my location of the word difference has moved. So we say we are whatever percent confident that the population mean of the differences. There it is. Or some people say mean difference. I love that. That's completely fine. In, and then you're going to have your context is between your lower bound and your upper bound. CI level goes here, right? Nothing new with that. Here's my context, which is my variable and my objects put together, my lower bound and my upper bound. Now, you know, when we're studying the difference between anything, we always have a follow-up statement because we want to mention if we have a difference. So this interpretation just tells us, okay, what the values are, right, of our bounds. But then we have that follow-up that explains, okay, well, what is the CI telling us, right? So we're going to say plus follow-up, and we'll look at that in the next page. But I want to squeeze that in here, so when you're looking at your notes, you know, okay, that follow-up is there. So let's take a look. The follow-ups are no different than anything we've done last class, or even for the proportions. Okay. So remember, for the follow-up, we have three different scenarios, right? So we have an all positive CI, we have an all negative CI, or we have that CI goes from negative to positive. So when we have this CI that goes negative to positive, that means there is no difference. Here, and we have 0 in the CI. Just going to write these quick, okay? These two indicate that there is a difference. Because either the 0 is above or below, so the 0 is not in CI. Remember, if it's all positive, then group 1 is larger. So order of subtraction matters, right? I'm just going to make a note here. So for positive to positive, group 1 is larger. If we have negative to negative, group 2 is larger. Okay, so the same thing. So I'm not going in great detail because we already know this. We know this from last class, and we know it from the last section where when we were studying categorical data. Okay, so that's my CI follow-up. So nothing unusual there. Remember, what you want to mention is, oh, my CI is all positive. Since it's all positive, it does not include 0. So I am showing there's a difference, and that difference is that group 1 is larger, but you're just going to put in context, right? So maybe we're looking at siblings, we would say the older siblings have a higher average if my CI comes out all positive, right? So you're just taking that step further than just saying, oh, well, these are the bounds. Well, what do they mean, right? What is it telling me about that difference? So you're going to notice everything's like the same as last class. We're still studying the same thing. It's just when you have paired data, it's a better calculation. It's like tighter, right? So it's less variability, okay? So it actually gives you a better answer. You just can't always do it because we don't always have paired data. So let's take a look at the hypothesis test. Everything's going to look pretty similar. This is going to be the paired t-test when we're looking at Minitab. Okay. We're going to, of course, look at the whole complete testing process. So let's take a look at the population step. So for a population step, I don't really think much changes except for my unknown from last class. So in my population, I want to talk about the objects, and these are really that I have two populations. You don't have to go into great detail for these. The two populations, these are just the two groups that we're studying. So we could say the two groups that we're studying are older siblings and younger siblings who take Stat 2 at RIT, right? That's like that. Those are who we're studying. Those are the people that we're studying. That actually was really detailed. You could just say older siblings and younger siblings. That would be less detailed. Okay? I'm not super picky as long as you identify who it is, right? You don't have to be too terribly detailed. Remember, like last class, we have one variable that we're studying between the two. So one variable for both samples, right? So for our example, it was their average in the Stat 2 class. And I think recognizing the variable and naming the variable is so much easier and quicker in numerical data than categorical. Some people asked last week if they could still word this as a question, the variable, and absolutely you can. You could say, what is your average in your Stat 2 class, right? That would be a way of asking. And that's fine. My unknown here, this is the change. So last class, I had 2 unknowns, right? I had 1 for each sample. Remember what we're studying here with a pair T? We're studying the mean of the differences. So my unknown here is mu D, okay? So mu D is the population mean of the differences. And then in whatever your context is, okay? So you're going to fill that in. And remember, the context is just the objects and the variable put together. Okay. And then of course, my goal is always to support my HA. And I want to think about what my HA would be. So when we're studying the difference of things, the null is always that they're the same, right? The HA is always that something is different, something has changed. So I want you to think about that. My goal is now to show that something is different. And the problem will tell us, right? So it will tell us if it's, greater than, less than, not equal kind of thing. So we're going to have very similar goal to last class. So we're just going to say to show a difference. And you can get the wording right from the problem between the two populations. So it might say, well, the mean of the differences is greater than or less than or not equal, right? So just know it's not always a not equal, but it could be. So let's take a look at this method step and how we would write this. And I don't think it's going to be a surprise, really, but just keep in mind my unknown is mu D. Okay? So in my method, I'm going to use that mu D. So for my method, I have my null, and my null is always going to be that mu D is equal to 0, meaning that when I subtract the 2 and I take the average, it's 0. Remember, when I say this, I mean statistically. So statistically close enough to 0 to say that there's no difference. Okay, I want you guys to realize that when we're doing all these things, it might not be exactly 0. What we're saying is that it's close enough to 0, statistically close enough to 0 to say that there is no difference between the two populations. Then my HA, I'm just going to write it over here. My HA can be that the mu D is not equal to 0, less than 0, or greater than 0, right? So this never changes, and this is always going to be mu D, one of those, right? There's not really room for error in there other than if it says less than in the problem, you choose greater than or not equals, right? That's where your error will come in. Remember my alpha, we're going to identify this. Normally it's 5%. It could be something a little different, like 1%, or be given something. And we're still studying the T-curve. So I'm just going to mention my T-test statistic. And I'm just going to mention degrees of freedom. You can say it's n minus 1. You don't have to. Just mentioning degrees of freedom is enough for me to understand that you know that this changes my curve, right? That number is changing everything. Okay. All right. So let's take a look at our sample step. Of course, in our sample, we're going to have our mini tab, and we're going to check our requirements. So I'm just going to say requirement check on the differences. You know why I keep saying this? For the requirements, and I wrote it out so much, and I'm saying it again because I see mistakes happen here. I see people just do it for each individual sample, and that's not what you're supposed to do. It's on the differences, because that's actually what we're studying now. Okay, so we're going to check for normality, and we're going to check for outliers. So last class, we had to do it twice for normality and do this twice for outliers, only once now for each, right? One normality check and one outlier check. And then you're just going to make a quick little statement, right? Nothing too crazy here. So my result step, same as usual. I'm just going to, you can report your test statistic and your p-value, but I want you to know you don't have to. What I'm going to look for is the statement. So the mean, so you could say the mean difference or the mean of the differences. But if you tell me it's the difference of the means, that means something totally different to mean. I'm sorry, I keep using the words mean and different. That has a different understanding of what's going on, right? If you say the difference of the means, think about it. You're subtracting your means. That's what we did last class, right? That's not what we're doing this class. And that's why this order matters. What we're doing this class is we're calculating the mean after we calculate the differences, right? So we're just calculating the average on the one column of the differences. And that's why I'm particular about it, because the understanding between the two, the order here makes it understand what's going on different. So the mean of the differences is whatever my test statistic is. Now I want you to understand, and I had someone ask me this, and we kind of had a conversation about this, that it sounds like, oh, the mean is this. No, I'm not saying that. I'm saying that this average of all the differences is this number of standard errors below or above my 0, right? That's what this is saying. So here I'm going to put my test statistic here. So my mean of the differences is this many standard errors above or below my center, which is 0, right? Whenever we're calculating the difference, that center, that mu naught, that h naught is 0, right? And then I'm just going to mention with my degrees of freedom, oops, I like jump ahead when I'm writing. That just came out really bad. I gotta change this. I'm sorry. This like looks totally different than what I really wanted to write. So with degrees of freedom equal to this. You know what happens? I just start talking and then I start writing what I'm saying, but I'm like off. So I start messing everything up. Okay. So I want to mention my degrees of freedom, and they're just n-1. You can look at this, but we could just calculate it quickly in our head, whatever n is. Okay. Of course, here, my results, I'm going to report my p-value. I do not need to interpret this value. We're just going to report it. And then my conclusion, which my conclusion is the same thing as always. So I'm just going to squeeze it in here. So I have a couple things. Is the p-value less than or equal to my alpha? It's going to be a yes or a no. If it's yes, then we can reject. Oops. See, there it goes. Reject, it must be because it's Monday. Reject my null. And if it's a no, then that means I just cannot reject my null, right? And then I'm going to have my same statement. Okay. So my same conclusion statement, which I look for the level of significance, if my sample does or does not support, and then your goal, right? And then sometimes we have to do like a little, I don't want to say a follow-up, but sometimes you'll see where I do an example where, like, what does that mean to us? Okay, what is that saying to us about the problem? Like, is it actually showing a difference? That kind of thing. Okay. So are there any questions on this so far? In the write-up, the steps? I feel like it's pretty much what we always do. Let's take a look at example 1 on page 9. I'm just going to squeeze this in here so I don't bring in a whole piece of paper for that. So I'm going to take a look at example 1 from page 9. This example is going to look very similar to last class, but I want you to see it. So you can see that difference for paired versus independent. And then we're also going to look at example 2, which is on, I don't know. I don't know if I have this right page. I'm not sure what page example 2 is on. I have to look. I have page 4 written down. I find that hard to believe. So we're going to also look at example 2, and we'll discuss that. I'm sorry, I don't have that written down. I don't think properly. Okay, so I'm going to share my screen. Of course, guys, you can follow along by downloading the notes yourself and working through all the steps on your own as I'm walking you through it, or you can just watch me. Doesn't matter to me. Both are pretty good. So I thought I had the notes. Oh, I do have the notes downloaded. Here we go. Okay, I do. I'm just not. Okay, right here. Is this page 9? It's not. This is page 4. Interesting. Okay, so I apologize. Page 4. I need to change that. It's on my notes on my side. Okay, so on page 4, we're going to look at example 1. Sorry about that. And for this example, we're actually going to look at the same example we studied last class. So here we're looking at that, those patients at that Pennsylvania Medical Center where we collected the cholesterol levels of heart attack patients, right? Do you guys remember this from last class?
That's right.
Remember that data set had a whole bunch of data, right? It had the cholesterol levels of heart attack patients 2 days after their heart attack, 4 days after, and then 14 days after. And then we had, we collected data on a control group, right? So people that weren't linked to the previous patients. And what we did last class is we compared 2 days after someone's heart attack to someone completely different that never had a heart attack. Today, what we're going to do is we're going to look at dependent or paired data. And we're going to look at the same patient and we're going to look at their cholesterol levels 2 days after their heart attack and that same patient 14 days after their heart attack. That's what makes this paired, okay? That we're looking at the same person just 2 days after and then 14 days after. So that's paired data. It's still numerical because we're studying a meaningful number and we want to know, if there's a difference in their means. Right? So look at right here. It says we want to know right here, mean cholesterol, right there. Numerical, okay, when it says mean. So we want to know if those levels have decreased over time. When I read that, I just start thinking about, okay, what is my HA going to be if I'm doing a test or if I'm looking at a CI? What am I looking for? What is, how do I want to answer this question? So here we're just going to look at, I think I have the test, but I really wanted to look at the CI for this. But we're going to look at if there's a difference where it's decreased. So I want to know if day 2 is larger than day 14. So for a CI, that would mean that I would have an entirely positive CI if group 1 was 2 day and group 2 was 14 day, right? So I just kind of think ahead, that's what I'm looking for. If I'm looking at a testing process here and I want to know if it's decreased, you're going to look at the same idea as a CI. If group 1 was 2 day and group 2 is 14 day, we're looking for it to be positive because it would be a larger number minus a smaller number. So that would mean the mu D is greater than 0. So I just want you to, kind of see that in that idea that we have there. So this is their testing process. I wanted to really do a CI. So I wanted to kind of look, see if I have a CI in here. Maybe this is why I had the wrong page. It is why I had the wrong page. Because I do really want to look at page 9. I'm sorry. I do really want to look at page 9 because I want to look at the CI, but page 4 has the testing process. So there you go. I was right and I second guessed myself. Okay. So let's build a 95% confidence interval and we want to know if the mean level has decreased over time. So let's go into Minitab. I've already downloaded my Minitab. Feel free to do that, to download it. It's the same file as last class, but if you notice when you look at it, I took the column 4 out. I took that control group out of the mix because we're only looking at paired data and I didn't really want anyone to get confused by that, but it's really the same file as last class, just missing that column 4. Okay, so we're going to compare column 1 and column 3. I want you to know you can just click on this and then you can delete the whole column. You could delete all the cells, but you could delete the whole column somewhere in here. And it's up to you. Some people like to do that just so it's less confusion, less information on their page. It doesn't matter to me. I typically just think, okay, I'm comparing column 1 and column 3, and I just keep that in my mind. All right, so my CI, remember we're gonna go to the same place that we go for a test, but we haven't used this yet. So we're gonna go up here to stat, go to basic stats, and right below the feature we were in last week, you will see our feature for today, which is the paired T. Gives you like a little explanation when you hover over it, and I love that. That's so helpful. So I'm going to click on paired T. Now I need to know, how do I have my data, right? This is always like a big deal. I have to know, is each sample in its own column, or do I have summarized data? That would mean that I have a column with the differences, okay? And I don't have that. I have each sample in its own column. Remember, sample 1 is going to be group 1, and the order of subtraction matters. I want group 1 to be 2-day, and then group 2 to be 14-day. And the reason why I want that is because I want to really look at these like what I was thinking about, that it's greater than, okay? Because I already had that in my mind, that that's how I was going to set up. You could set those up differently and it would be a less than. It's all if you switch those around. As usual, I'm always going to go to my options. It did ask me for 95% confidence level. We should know by now that that's the default level that we're going to see for a CI automatically here in Minitab. My hypothesized difference is always 0 for my differences, so I don't have to change anything there. And my HI, my alternative, is always going to be a not equals for the CI. Doesn't matter what we're looking for, right? We're looking for day 2 to be greater than 14. That doesn't matter for a CI. You always have the not equals, and then you manually yourself have to look for that difference. Okay. I'm just going to click OK. So we're going to get all this data. It's going to look kind of like last class where I have a lot of output. It's because I have 2 samples. But I don't, there's really no reason to get overwhelmed with it. You're going to get your test output here, but we don't need that. We're not really studying the test. What we're interested in is right here, the CI. So I'm going to copy and paste this and bring this over to my right up here. Okay, so here it all is. What I'm interested in is this part, my 95% CI. So right there, we're 95% confident that the population mean difference, MUD, mean difference in cholesterol levels from day 2 to day 14 is between the 13.7 and the 62.03. So since the CI is positive, that means 0 is not in my CI, I have evidence of a difference. So that difference is saying that the 2-day levels are higher. Okay, so we are showing that it has decreased over time. So I'm kind of like answering the question when I write my follow-up. Right? So that's my CI problem. So now I think I want to go back to page 4, and that's why my example 2 said page 4, I believe, because I wanted to look at my testing process, I believe, on this one. I do. Okay. So sorry about that, guys. I did have that. I had it written down and then I second guessed myself. All right. So page 4 was example 2. So I'm going to go back up here. And it's actually, I think it's still called example 1. I probably need to change that. Let's go up here. You know why I want to walk through this? I know you guys can do the testing process. I want to show you the Minitab, and I want to show you how to check those requirements. So here we're studying the same thing, but just now with a testing process, okay? So, so when we're looking at the testing process, we already talked about kind of what we're looking for the difference. We're looking at MUD is greater than, because I'm going to choose group 1 to be 2 days and group 2 to be 14 days. Okay, so let's look at this right up. So my objects, I'm just going to mention that the two populations are the patients 2 days after a heart attack and 14 days after a heart attack. I'm not going to go into great detail. I don't need to. My variables, which is that blood cholesterol level, it is numerical. You don't have to include this right here where it says numerical, but it is nice. Some people really like to do that. My unknown is always mu D. Mu D is always the population mean difference, and then whatever I'm talking about. So it's the population mean difference of cholesterol levels between those heart attack patients from 2 days after and 14 days after. I like to see this. I like to see that order of subtraction, because what you're telling me there is you're telling me how you're subtracting, and this is what drives all of this. Okay, so your order of subtraction that you're telling me up here drives what you have for your inequality for your HA. Okay, which drives your goal. So if someone told me it was day 14 minus day 2, that is nothing wrong with that. It just means then you're going to have a less than symbol here. Okay, so I really need to see this because it doesn't necessarily come right from the problem. So I do like to see that, or something that at least interprets that. My goal is to say that the population mean cholesterol levels for the heart attack patients 2 days after is greater than the cholesterol for 14 days after. Okay, or you can say that the population mean difference in cholesterol levels from 2 day to 14 day has decreased over time, right? That was right from the problem. You can write your goal a couple different ways. Remember, it's always to support my HA. So my null down here is it equals, my HA is greater than. Alpha, again, I still have it at 5%, which I know we discussed last class. I probably should change that to 1. I'm studying my t-test statistic with degrees of freedom. My mini tab, we're going to get to that in a minute, and we're going to check the requirements, okay, for my sample step. So let's go ahead and open up mini tab again so we can take a look at that. So we already know the testing process, but remember, I need to change my HA so it's not a not equals, right? This was a not equals for the CI. So I'm going to go back to the same place, stat, basic, paired T. I can leave everything the way it was, except for in options. I want my alternative hypothesis to match my alternative hypothesis, my write-up. And remember, that was a greater than because of the way I chose my sample 1 and sample 2. Just click OK twice. And I get my output here. And remember, what I'm interested in is the bottom, the test statistic, and the p-value. Okay. But while we're in here, we'll check our requirements because we need to put this in this sample step anyways. Remember, the requirements have to be done on the differences. I don't have a difference column, right? And yes, Minitab did this testing process on the difference. It's just, it does it in the background. It doesn't actually give me a column. So I need to have a new column, and maybe I'll just put difference here. And I need to have the differences here. I want to keep my order of subtraction the same, meaning it's 2 minus 14, right? Day 2 minus day 14. So I'm going to go up here. I'm going to click on calc. This is just going to use my calculator function. So I'm going to click on my calculator. So it says store your results where? So I want to store them in column 5 where I named it difference. So I'm going to bring that over. Now it says my expression. What is my expression? What do I want to do? I want to take my column 1, bring that in. I'm going to subtract my column 3. Okay, you guys see that? So I just took column 1, mine, and I typed in the minus here. I don't know if you could use your keyboard. Probably, I don't know, I just didn't try it. Minus my day 14, and it's going to be stored in my difference column. You could always name the column afterwards. I just did it before. Just going to click OK, and you're going to see this column pop up. So let's just take a look at this column. Here it is. So I got positive difference and negative, positive, 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 negative, positive, right? So you can see it. And I have some of these asterisks in there. What do the asterisks mean? Remember last class I told you the asterisk just means that this person didn't show up to their appointment. So if they didn't show up to the day 14 appointment, then that means I don't have a number to subtract from the day 2, right? So I'm just going to have an asterisk in those, and it's okay. Minitab is fine with that. So it just means I don't have data for that person. Okay, so that's what that data looks like. You don't have to look through it. I'm just showing you what it looks like. So now let's go ahead and check our requirements. We're going to check our requirements like we did before. So I'm going to check my requirements by checking my normality. So I'm going to go to graph. And the reason I just want to tell you, I'm going to use an NPP so I don't have enough data values. Right here, look at this, 19. Okay, so 19 is not enough. My degrees of freedom is 18, by the way. So I'm going to go ahead and look at an NPP. So graph, probability plot. So click on that one. I'm still going to do single, and I'm just going to choose column 5, my difference column. I don't have to choose anything special. Just click OK. I'm going to get my NPP. Remember what I want here. I'm going to bring this into my output, but look at my p-value is 0.224. As long as that's greater than 0.05, I'm good to go, meaning that I have shown normality. So you'll just do your little mini write-up about that. All right, let's take a look at a box plot of this data. So because we don't want any outliers. So I'm going to go to graph, box plot. Again, just a simple box plot. I have one column of data. I'm just going to choose the correct column, which is the differences. You can add different things. You don't even need to, because what I'm really studying is if I have any outliers. Remember, I'm going to look, nothing on the top and nothing on the bottom, so good. So I've met my requirements. I'm going to go back over to my write-up and copy everything in so you can see everything's here, right? And I just do a little write-up about my NPP right here with a p-value of 0.224. We have met the assumption of normality. I really should mention, because my null is that I have met normality and my HAs that I have not. And we don't have any outliers. Okay. So my results, I'm going to say that my mean of the differences is 3.29 standard errors above 0. So if you picture your normal curve, you're on the right side, 3.29 standard errors from the center, right, of 0 with 18 degrees of freedom. My p-value is 0.002. So yes, my p-value is less than alpha. We can reject the null. So at the 5% level of significance, the sample does provide evidence to say that the population mean cholesterol level for heart attack patients 2 days after is greater than those 14 days after. Okay, so I am showing a difference. I am showing that it's decreased. So you can see down here, I do write it in that way, where I am showing that it has decreased over time.
Professor, this is Judy. Can you assign me the captioning, please?
Yeah.
Thank you.
Any questions on that, guys?